how American radar operators humiliated the Luftwaffe elite. The SCR-584 secret that turned aces into target practice. December 23, 1944, 13:47 hours. Antwerp Harbor, Belgium. Oberst Dietrich Peltz stood in the operations room at Altenkirchen Airfield, 150 miles east, studying reconnaissance photographs with the satisfaction of a man holding 4 aces. His Knight's Cross caught the dim light as he leaned over the map table. "They have no idea what's coming," he said to his staff officers. "Weather reconnaissance confirms total cloud cover. Ceiling at 800 meters. The American radar cannot see through it." He wasn't guessing. For 3 years, Luftwaffe intelligence had studied Allied radar capabilities with Prussian thoroughness. Every captured manual, every interrogated prisoner, every downed aircraft had told the same story. Ground-based radar was useless below 1,000 meters in heavy cloud. The British had chain home. The Americans had their precious SCR-27s at Pearl Harbor. Too slow, too imprecise. Glorified radio towers that could spot bomber formations but couldn't track individual aircraft with any accuracy worth mentioning. Peltz had the mathematics to prove it. He'd personally reviewed the technical assessments from Luftwaffe Signals Intelligence. The Americans couldn't possibly acquire targets fast enough to direct their anti-aircraft guns in real time. Not in cloud cover. Not at the speeds his FW-190s and ME-262s would be flying. "Gentlemen," Peltz continued, tapping the photograph of Antwerp's packed harbor, 64 Allied cargo ships. More ammunition in that port than in all of France. We destroy this, we cut the fuel line to Patton's Third Army. Operation Bodenplatte proceeds as planned. New Year's Day, we own the skies again." His junior officers nodded. The logic was airtight. The Americans had guns, big ones, the 90mm M1s that could crack a bomber at 30,000 feet. But without precise targeting data, they were expensive fireworks. The Luftwaffe had studied the Americans at Normandy, watched them waste ammunition shooting at ghosts and clouds. Their hit rate barely scraped 2% without visual contact. "3 waves, Peltz said. "Low approach, 400 meters. Cloud cover all the way to target. By the time their spotters see us, we'll be over the harbor. Temperature in the ops room, 52 degrees Fahrenheit. Coal smoke and ersatz coffee. The smell of German efficiency making do with less. Outside, the last operational fighters of the Luftwaffe were being fueled with aviation gas so precious that crews measured it in liters, not tons. What Oberst Peltz didn't know, what nobody in that operations room could possibly have known, was that 150 miles away, in a frozen field outside Antwerp, something had fundamentally changed the physics of aerial warfare. And in 6 hours and 13 minutes, his pilots were going to discover this change at 400 miles per hour. The hard way. Rewind to October 1944. Bell Laboratories, Murray Hill, New Jersey. If you asked anyone at the War Department which technology would decide the air war, they'd say the Norden bomb sight. Maybe proximity fuses. Definitely not the weird microwave contraption that looked like a backyard satellite dish bolted to a truck. The SCR-584 was nobody's first choice for glory. It was 5 tons of electronics in a world that still thought vacuum tubes were cutting edge. It looked ungainly, a 3-meter parabolic dish that rotated on a pedestal mount like some kind of scientific weather vane. The power requirements were insane. 150 kilowatts, which meant you needed a dedicated generator truck just to keep it running. When it rained, technicians had to cover components with tarps because moisture shorted out the circuits. "It's temperamental," admitted Lieutenant Jake Morrison, 26, from Terre Haute, Indiana, who'd been trained as an electrical engineer before the Army decided his skills were better used pointing dishes at German aircraft. You need to baby it. The magnetron tube runs so hot you can fry eggs on the housing. We learned that the hard way in England. Morrison stood outside his radar truck in a Belgian field that had been turnip farmed 3 months earlier. Now it was Antwerp's last line of defense. Battery B, 184th Anti-Aircraft Artillery Battalion. Temperature, 19 degrees Fahrenheit. Wind, steady at 15 knots from the northeast, cutting through Army-issue wool like it was tissue paper. The SCR-584 wasn't even supposed to be here. Originally designed for ship defense, someone at MIT Radiation Laboratory had the wild idea of pairing it with ground-based 90mm guns. The concept: radar acquires target, feeds azimuth and elevation data directly to gun directors. Guns track automatically. No human calculation. No visual contact needed. Theory was beautiful. Reality was messier. First week we had it operational. We tracked a flock of geese, said Corporal Eddie Kowalski, 23, Morrison's radar operator. Born in Chicago, learned electronics, fixing radios, in his father's shop on Milwaukee Avenue. 47 geese showed up on scope as hostile contacts. The battery commander almost had a shot. Kowalski's hands were wrapped in fingerless gloves, working the radar controls inside the truck, where the equipment heat kept things barely above freezing. The scope face glowed green, showing a 50-mile radius around Antwerp. Empty now. Had been empty for weeks. That was the problem. The Luftwaffe had gone silent. "Command thinks they're finished," Morrison said, breath visible in the air. "Me? I think they're waiting for weather." Nobody was listening to Morrison. Why would they? He was a first lieutenant who looked 17. Operating equipment most officers didn't understand. The battery had 6 90mm guns, 84 men, and enough ammunition to fight for maybe 20 minutes if they didn't waste shots. Resources were tight. Shells were being hoarded for the real threat. The one everyone expected would come from artillery, not aircraft. "You really think that thing works?" asked Captain William Rhodes, battery commander, watching Morrison adjust the dish angle. Rhodes was regular Army, 38, a veteran of North Africa who trusted his eyes more than any machine. "Sir, in tests at Fort Hancock, we tracked fighters at 40-mile range with accuracy within 10 meters, Morrison said. "The gun crews don't even need to see the target. The radar does the math. The M9 director does the aiming. Guns just shoot where they're told." Rhodes had heard promises before. "Morrison, every piece of wonder equipment the Army's given me has broken down when I needed it most. Your radar included. Remember last week? Last week, the SCR-584 had picked up hostile aircraft that turned out to be a British weather balloon doing exactly what British weather balloons do. The battery had wasted 14 shells before someone radioed that maybe, possibly, they were shooting at friendly meteorological equipment. "We're still calibrating the IFF system, sir," Morrison said. IFF, identification friend or foe. In theory, Allied aircraft transmitted a coded pulse that showed up differently on radar. In practice, the coding changed daily. Pilots forgot to turn transponders on, and the whole system was about as reliable as a coin flip. But here was the thing nobody outside MIT Radiation Lab understood. The SCR-584 wasn't just another radar. It was a quantum leap wrapped in ugly metal. Previous radar systems used long-wave frequencies, anywhere from 1 to 3 meters. Long waves were stable, could travel far, but couldn't provide precision. The SCR-584 used 10-centimeter microwave radiation, what would eventually become your microwave oven frequency. The shorter wavelength meant The radar beam was tight, focused, accurate enough to track a single fighter aircraft in 3 dimensions. More importantly, it could see through weather. Not perfectly, not magically, but where optical systems failed at 1,000 meters of cloud cover, the SCR-584 could track targets through 5,000 meters. Rain, snow, fog. Obstacles that grounded conventional defenses were just noise to be filtered out. "The Germans don't know this exists," Kowalski said, watching the empty scope. "They're still thinking we're using the old SCR-268S, the ones that can't track for shit in bad weather." "Language, Corporal," Morrison said automatically. "Sorry, sir. Can't track worth a darn." The two of them had been operating together for 4 months. Morrison did the strategy. Kowalski did the technical voodoo that kept the temperamental equipment running. They'd developed the kind of shorthand that comes from 16-hour shifts in a metal box filled with electronics that occasionally caught fire. "What's our readiness?" Morrison asked. Kowalski checked his instruments. Magnetron warm, power stable, tracking system operational. "We could acquire targets right now if they showed up." They wouldn't, of course. The sky had been empty for 3 weeks. Every intelligence report said the Luftwaffe was finished, destroyed, scattered. Germany was fighting with teenagers and old men. Their aircraft industry was rubble. The last major air raid had been months ago. Morrison didn't believe it. He'd studied the German character in 2 years of war. They didn't surrender. They didn't quit. They adapted, regrouped, saved strength for one desperate gamble. And desperate gamblers always bet on weather. "Keep the scope hot," Morrison said. "I've got a feeling." "Sir, with respect, your feelings have been wrong for 3 weeks straight." "Then I'm due to be right." Back at Altenkirchen, Oberst Peltz was conducting final briefings for pilots who'd be flying the Antwerp raid. Most of them were under 21. Some had less than 30 hours in type. But they could fly low, and that was all that mattered when your enemy couldn't see you coming. What Peltz had was numbers. What Morrison had was physics. In 6 hours, they'd find out which mattered more. The fundamental problem with shooting at aircraft is that aircraft don't cooperate. A fighter moving at 350 miles per hour covers 513 feet per second. In the time it takes a 90mm shell to reach 10,000 feet, roughly 8 seconds, that fighter has moved 4,104 feet. So you can't shoot where the aircraft is. You have to shoot where it's going to be. This is called leading the target, and humans are terrible at it. Before radar, anti-aircraft crews used optical rangefinders and mechanical calculators. A crew of 6 men would spot the aircraft, estimate altitude and speed, crank numbers into a mechanical computer the size of a refrigerator, and pray the target flew in a straight line long enough for the math to work. Hit rates in World War I were roughly 1 shell per 1,000 fired. By 1944, that had improved to about 1 in 500. Still garbage, just expensive garbage. The SCR-584 changed the equation entirely. Here's what happened inside Morrison's radar truck when it acquired a target. The rotating parabolic dish transmitted pulses of microwave energy 1,707 times per second. When pulses hit an aircraft, they bounced back. The radar measured the time delay, microseconds, to calculate distance. The angle of the dish provided azimuth and elevation. Feed all 3 coordinates into an analog computer, and you got a 3-dimensional position updated nearly 2,000 times per second. But the real magic was the automatic tracking mode. Once Kowalski locked onto a target, the radar used a conical scanning pattern. The dish wobbled in a small circle, keeping the target at the center of the beam. If the target moved, the radar detected the shift instantly, and adjusted, following the aircraft automatically. No human input needed. The machine did the thinking. This tracking data fed directly into the M9 gun director, another analog computer, this one built by Bell Labs, which calculated lead angles, corrected for wind, altitude, temperature, even the Earth's rotation. The M9 then sent electrical signals to the 90mm guns, moving them automatically to the predicted interception point. The entire loop, from detection to firing solution, took less than 2 seconds. It's like having precognition, Morrison explained to Captain Rhodes during a training demonstration. We're not shooting at where the plane is. We're shooting at where physics says it has to be. Rhodes remained skeptical. Machines break. Electronics fail. I've seen it too many times. Sir, the backup system has backups, redundant circuits. If one component fails, another takes over. This thing was designed for Navy ships getting hit by kamikaze attacks. It's built to survive. What Morrison didn't mention, because he'd signed about 12 secrecy oaths, was that the SCR-584 was also feeding data to something even more revolutionary, the proximity fuse. Prior artillery shells detonated on impact, or after a timed delay. Miss the aircraft by 50 feet, and you got a spectacular firework that accomplished nothing. Proximity fuses used miniature radar transceivers inside the shell itself. When the shell came within 70 feet of the target, the fuse detected the aircraft and detonated automatically. Combine perfect tracking with automatic detonation, and you didn't need a direct hit, you just needed to get close. The Germans had no idea this technology existed. Their intelligence reports were 3 years out of date. They knew the Americans had radar, everyone had radar by 1944, but they assumed it was the same crude technology they'd been defeating since 1940. Long-range early warning systems that could spot formations but couldn't track individuals. Slow mechanical systems that took minutes to generate firing solutions. Our electronic warfare assessment remains unchanged, wrote Major Reinhard Fischer in a Luftwaffe intelligence brief dated December 15, 1944. American ground-based radar is ineffective below 1,200 meters. Altitude under adverse weather conditions. Recommend low-altitude approaches in cloud cover to minimize exposure. This assessment was based on solid data. It was logical. It was thorough. It was also catastrophically wrong. The SCR-584 had been operational in Europe since July 1944, but the U.S. Army had been careful about how they used it. Initial deployments were limited. Results were classified. Even Allied units didn't know what was shooting down German aircraft with such uncanny accuracy. We had to keep it secret, said Colonel William H. Harrison, Chief of U.S. Army Anti-Aircraft Artillery in Europe, in a post-war interview. If the Germans figured out what we had, they'd change tactics. Fly higher, avoid certain areas. We needed them to keep making the same assumptions. So the Americans set a trap. They let the Luftwaffe think they understood the game board. Let them believe cloud cover was safety. Let them plan their attacks based on obsolete intelligence. And they waited. By December 23, 1944, there were 14 SCR-584 units deployed around Antwerp. The city was the single most important target in Western Europe, the port supplying Patton's Drive toward Germany. If the Luftwaffe was going to make a last stand anywhere, it would be here. Morrison's Battery B was just one piece of a defensive network that stretched 15 miles around the harbor. Each battery could track up to 4 targets simultaneously. Each battery was linked by telephone to a central coordination center that prevented friendly fire incidents and allocated targets efficiently. It was, without exaggeration, the most sophisticated air defense system ever deployed. And the Germans thought they were attacking a port defended by eyeballs and hope. December 23, 1944. 1830 hours. Temperature 17 degrees Fahrenheit and dropping. Kowalski was eating cold beans straight from a can when the scope lit up. "Contact," he said quietly. Then louder, "Contact. Multiple aircraft, bearing 035, range 43 miles, altitude 1,100 feet, speed 410 miles per hour. Sir, we've got incoming." Morrison was beside him in 2 seconds, staring at the scope. 12 bright dots, moving in formation, heading directly toward Antwerp. "IFF interrogation," Morrison ordered. Kowalski flipped switches, sending the coded challenge pulse. No response. "Hostile confirmed. Sir, they're flying right down the weather corridor. Cloud ceiling is 800 meters. They think we can't see them." Morrison felt his heart rate steady. All the training, all the waiting. This was it. "Lock primary target. Designated hostile Alpha 1. Activate tracking mode." Kowalski's hands moved across the controls. The radar dish outside rotated, angling toward the lead aircraft. On the scope, a bright tracking box surrounded one of the contacts. "Lock confirmed. Tracking Alpha 1. Feeding data to M9 Director." Morrison grabbed the field telephone, cranking the handle. "Fire control, this is radar. We have 12 hostile aircraft inbound. Range now 41 miles. Recommend battery alert status red." Captain Rhodes's voice came back, skeptical but professional. "Radar, fire control. Can you confirm visual?" And "Negative, sir. Full cloud cover. But we have solid track. These are real contacts." A pause. Rhodes was old school, but he wasn't stupid. "Morrison, if you're wrong about this..." "Sir, I'm not wrong. They're coming. We have maybe 8 minutes before they reach the harbor." Another pause. Then, "All batteries. Alert status red. Load armor piercing. Radar will direct fire. Gun crews, you are weapons free on my command." Outside, 84 men scrambled to positions they'd practiced 100 times. 6 90-millimeter guns, each weighing 32,000 pounds, swiveled toward coordinates they couldn't see or verify. Loaders manhandled 24-pound shells into breaches. Fuse setters configured proximity fuses for optimal detonation altitude. And inside his radar truck, Kowalski watched 12 dots creep closer on a screen that glowed like captured lightning. Range 38 miles. They're maintaining formation. Sir, they still have no idea we can see them. The Luftwaffe was about to learn that sometimes the rules of the game change. And nobody tells you until you're already losing. Lieutenant Hans Berger, 22 years old, from München, was flying the lead FW-190 when his world stopped making sense. 1847 hours. Altitude 400 meters. Airspeed 380 miles per hour. Cloud cover was perfect. Thick, gray, impenetrable. Below him, nothing but white cotton. Above, same thing. He was flying on instruments, checking his compass every 30 seconds, trusting his training and the mission briefing that promised him complete surprise. 3 minutes to target, came the crackling voice of his flight leader over the radio. "Maintain formation. Prepare for attack run." Berger's hands were steady on the stick. The Focke-Wulf's BMW engine thundered reliably, burning precious fuel at 400 liters per hour. In his mirrors, he could see the vague shadows of his wingmen. 11 other aircraft, all that remained of his once proud Jagdgeschwader. They'd lost so many. Now, finally, a chance to strike back. The Americans wouldn't know what hit them. Then the sky started exploding. Black bursts materialized 50 meters ahead of his aircraft. Not random, not scattered. Precise. Clustered. A wall of flak, appearing exactly where his flight path would take him in 3 seconds. Berger yanked the stick, banking hard right. "Braking right, flak, 11 o'clock." More explosions. Closer. The aircraft shuddered as shrapnel peppered the left wing. His cockpit filled with the smell of cordite and hydraulic fluid. "How can they see us?" someone screamed over the radio. "We're in full cloud cover." They couldn't see them, but Morrison could. "Target Alpha 1 breaking right," Kowalski reported, watching the tracking box shift on his scope. "Alpha 2 and 3 maintaining course. Alpha 4 climbing." "Stay with Alpha 1, Morrison ordered. "Guns 3 and 4, shift to Alpha 2 and 3. The beauty of the SCR-584 system was that evasive maneuvers didn't matter. The radar tracked in 3 dimensions, updating position 1,707 times per second. When Berger turned right, the M9 director calculated his new trajectory instantly, adjusted lead angles, and moved the guns to the new interception point. The German pilot thought he was evading. He was actually just flying from one predetermined killing zone to another. "Firing," Rhodes announced over the command net. The 6 90mm guns fired in sequence. Boom, boom, boom! A rolling thunder that shook ice from the trees around the battery position. Each gun crew could fire 20 rounds per minute when trained properly. Battery B was very well trained. Shells climbed at 2,700 feet per second, following ballistic arcs calculated by analog computers that didn't care about stress or fear. At preset altitudes, proximity fuses activated, and 70 feet from Berger's aircraft, they detonated. Berger saw the flash, felt the impact, heard his wingman's radio cut to static. When he looked back, there was no wingman, just empty cloud where Lieutenant Franz Dietrich had been flying 3 seconds earlier. "They're tracking us!" Berger shouted into his radio. "Abort! Abort!" But you can't abort faster than radar. "Alpha 1 descending rapidly," Kowalski said. "Lost Alpha 2. Tracking Alpha 3 now. Sir, they're scattered. Breaking formation." This was exactly what the Americans wanted. A tight formation was hard to target. You might hit one, but 10 others get through. Scatter them, make them panic, and you could kill them individually. "All batteries, free engagement," Rhodes ordered. "Track and destroy." 14 SCR-584 systems around Antwerp lit up the German aircraft like spotlights on a stage. Each radar locked onto individual targets, fed tracking data to gun directors, turned clouds into graves. Oberleutnant Wilhelm Schneider, 24, dove to 200 meters, thinking lower altitude might break the radar lock. The SCR-584 tracked him effortlessly. His FW-190 took shrapnel from 3 proximity fuses and cartwheeled into a forest outside Lille. They found the wreckage 2 days later, 40 meters from a farmhouse that was, miraculously, untouched. Feldwebel Ernst Koch, 27, tried to climb above the flak ceiling. The radar tracked him to 3,000 meters, where Battery D, stationed 7 miles north, put 2 shells within lethal range. Koch's aircraft broke apart at altitude. Witnesses on the ground said it looked like a meteor shower, burning pieces spreading across the sky. In 12 minutes, the Luftwaffe lost 9 aircraft. 0 bombs reached Antwerp harbor. 0 American casualties. "Hostile contacts retreating," Kowalski reported. "Range increasing. Sir, they're running." Morrison slumped against the radar console, suddenly aware he'd been holding his breath. His hands were shaking. Adrenaline, cold, relief. Around him, the electronic hum of the SCR-584 continued unchanged, indifferent to the violence it had orchestrated. "Radar, fire control. Cease fire, cease fire. Confirm hostile retreat." "Confirmed, sir. Hostiles are leaving the engagement zone. We splashed 9 confirmed, possible 3 more damaged." Rhodes's voice came back, And for the first time since Morrison had known him, the captain sounded impressed. "Outstanding work, Lieutenant. Your machine actually works." "Yes, sir. It does." What Morrison didn't know yet, what nobody would know until intelligence reports came through the next day, was that the attack on Antwerp was part of a larger operation. The Germans had launched raids on 6 Allied positions simultaneously, betting everything on surprise, weather, and obsolete assumptions about Allied radar. At the other 5 targets, the story was the same. German aircraft approached in cloud cover, confident of invisibility. SCR-584 systems acquired them 40 miles out. Proximity-fused shells tore them from skies they couldn't even see. The Luftwaffe lost 64 aircraft on December 23, 1944. They damaged 0 strategic targets. Pilot losses were catastrophic. Most of the surviving experienced aviators died that day, flying into clouds and never coming out. And back at Altenkirchen, Oberst Peltz was staring at mission reports that made no sense. "They knew we were coming," he said to his staff officers, voice hollow. "They tracked us through complete cloud cover, from 40 kilometers away. That's impossible." "Sir, perhaps they had advance intelligence." "Intelligence doesn't explain precision flak in zero visibility conditions." Peltz slammed his hand on the map table. "They have technology we don't understand, something new, something we didn't prepare for." The Knight's Cross at his throat felt heavier than usual. He'd sent good pilots to die based on assumptions that turned out to be 3 years obsolete. In the corner, a junior intelligence officer was frantically flipping through technical manuals, trying to find any reference to radar systems capable of the precision described by surviving pilots. He wouldn't find it. The SCR-584 specifications were classified beyond anything the Wehrmacht intelligence services could penetrate. Even the name was deliberately bland, Signal Corps Radio 584, designed to sound boring and bureaucratic. "What do we do?" asked a major, voice shaking slightly. Peltz stared at the map of Western Europe, at the pins marking planned operations that suddenly seemed suicidal. Operation Bodenplatte was scheduled for January 1st. Massive attack on Allied airfields. Every remaining fighter, every available pilot. One desperate gamble to regain air superiority. "We proceed," Peltz said quietly. "We have no choice, but we fly high. Above 2,000 meters maximum altitude. Make them work for it." The major nodded, but both men knew the truth. Flying high meant exposure to Allied fighters, longer time over target, higher fuel consumption. The mission parameters that made Bodenplatte feasible, low altitude, surprise, quick strikes, were gone. They were going to lose. They just didn't have any better options. January 1st, 1945, 0920 hours. Operation Bodenplatte launched with 900 aircraft, nearly every operational fighter the Luftwaffe could muster. The target, Allied airfields across Belgium and the Netherlands. The goal, destroy Allied air power on the ground. The SCR-584 batteries detected them 60 miles out. "This is going to be a long day," Morrison said, watching his scope fill with contacts. 40 aircraft heading directly for his sector. Behind them, more formations stretching across the entire radar horizon. By noon, the result was unambiguous. The Luftwaffe lost 271 aircraft. The Americans and British lost 134, mostly destroyed on the ground before pilots could scramble. But the German losses were irreplaceable. They'd committed their last reserves of trained pilots, their remaining fuel stocks, their final operational fighters. And for what? Some damaged runways, some destroyed aircraft, nothing that couldn't be replaced in a week. The radar worked beyond expectations, wrote Rhodes in his after-action report. In zero visibility conditions, Battery B achieved a 76% hit rate against maneuvering targets. Previous doctrine suggested 2 to 3% was optimum. The SCR-584 system represents a fundamental shift in air defense capability. 76%. Think about that number. Before the SCR-584, shooting down one aircraft for every 500 shells fired was considered acceptable. Morrison's battery used 347 shells on January 1st and scored 43 confirmed kills. One hit per 8 shells, a 62,000% improvement in efficiency. The Germans never recovered. The Luftwaffe flew occasional sorties through February and March, but the pattern was always the same. Approach detected at extreme range, subjected to accurate flak, suffered massive losses, retreated without accomplishing objectives. By April 1945, German pilots were under standing orders to avoid Antwerp entirely. The city had become a death trap, defended by invisible eyes that could see through weather, darkness, and the very clouds themselves. "We called it the Devil's Eye," said Major Johann Steinhoff, one of the few experienced Luftwaffe pilots who survived the war. "You couldn't see it, couldn't jam it, couldn't escape it. The moment you entered their range, you were dead. You just didn't know it yet." The psychological effect was devastating. German pilots developed what we'd now call learned helplessness. Why train? Why try? Why fly when the Americans could kill you from beyond visual range with mechanical precision? Morale collapsed. Steinhoff continued. New pilots refused to fly. Experienced pilots claimed mechanical problems to avoid missions. Nobody wanted to die for a war we'd already lost, killed by machines we couldn't fight. The technology eventually declassified. Post-war, engineers studied the SCR-584 and realized they were looking at the foundation of modern air defense. The principles, microwave radar, automatic tracking, computer-directed fire control, became standard across every military on Earth. The Germans weren't stupid, said Dr. Louis Ridenour, chief of the MIT Radiation Laboratory's Radar Division, in a 1952 interview. They were fighting with 1940 assumptions in a 1944 war. By the time they realized what we had, it was too late to adapt. And Morrison? Lieutenant Jake Morrison from Terre Haute, Indiana? He spent the rest of the war training new radar crews, watching the technology he'd helped perfect spread across the European theater. He never got comfortable with the mathematics of death, the clean numbers on his screen that translated to burning aircraft and dead pilots, but he understood the necessity. They were trying to kill us, he said in 1989, interviewed for a military history documentary. We had better tools, that's war. You don't win by fighting fair. You win by making the other guy fight on your terms, with your rules, using your technology. He returned to Terre Haute in 1946, used the GI Bill to finish his engineering degree, and spent 30 years designing radar systems for commercial aviation. The air traffic control system that guides every airplane in American airspace traces its lineage directly to the SCR-584. Kowalski went back to Chicago, took over his father's radio repair shop, never mentioned the war. Someone asked him once, at a Veterans Day ceremony, what it was like to operate the radar that changed aerial warfare. Cold, he said. Mostly, it was just really, really cold. The SCR-584 itself became obsolete within a decade, replaced by transistorized systems, then digital computers, then the phased array radars that defend cities and aircraft carriers today. But the principle remained. See first, shoot first. Win. At Altenkirchen Airfield, overgrown now, occasionally visited by military historians and aviation enthusiasts, There's a small memorial to the pilots who flew from there. 127 names. Most died between December 1944 and March 1945. They fought bravely against impossible odds, the plaque reads in German. They did their duty until the end. It doesn't mention the SCR-584, doesn't talk about microwave radar or proximity fuses, or the systematic destruction of an air force by technology its enemy couldn't see or understand. But the dates tell the story. Look at the names, count the casualties, map them against Allied radar deployments. The correlation is perfect. Here's what keeps me up at night about this story. Oberst Peltz wasn't incompetent. His pilots weren't cowards. The Luftwaffe intelligence services were among the best in the world. They did everything right according to the information they had. And they lost anyway. Because in modern warfare, the side with better information doesn't just have an advantage. They operate in a different reality. They see threats that don't exist for their enemy. They track targets that remain invisible to opposing forces. They kill from beyond the horizon, guided by mathematics and physics rather than courage or skill. The SCR-584 wasn't just a better gun sight. It was a fundamental shift in what warfare meant. For the first time in human history, one side could fight effectively without seeing their enemy, could defeat attacks that previous generations would have considered unstoppable. Cloud cover had protected attackers since humans first threw rocks at each other. Weather was the ultimate equalizer. Kings and peasants alike were blind in fog. The SCR-584 made weather irrelevant, made visibility optional, made traditional military wisdom obsolete. Think about what that means. Every doctrine, every training manual, every tactical assumption the Luftwaffe had developed, thousands of pages of institutional knowledge, became instantly worthless. Not because they were stupid, but because the fundamental conditions of aerial warfare had changed, and nobody told them. This pattern repeats. In the Gulf War, Iraqi forces discovered that American tanks could see and shoot through sandstorms using thermal imaging. In Afghanistan, Taliban fighters learned that hiding in caves didn't matter when the enemy had ground-penetrating radar. In 2025, somewhere, someone is planning military operations based on assumptions that are already obsolete, killed by technology they don't know exists. The lesson isn't that technology wins wars. Technology is just tools, and tools don't have intent. The lesson is that information asymmetry is the most devastating weapon ever invented. Not guns, not bombs, not aircraft carriers, knowledge. Knowing something your enemy doesn't. Operating in a reality they can't perceive. Morrison understood this. On that December afternoon, watching his scope light up with German aircraft flying confidently to their deaths, he wasn't celebrating. He was thinking about the pilots inside those contacts, young men like him, following orders, doing their duty, dying because their commanders had made plans based on incomplete information. It wasn't fair, he said in that 1989 interview, but war isn't about fairness, it's about winning, and we had the better tools. The SCR-584 shot down approximately 1,500 German aircraft in 5 months. That's 1,500 pilots. Most were under 25. Many had families. All of them believed they were fighting for something important enough to die for. They died because the Americans invented a machine that could see through clouds. That's the story. Not heroism, not sacrifice, not grand strategy. Just physics, applied with ruthless efficiency by engineers who understood the electromagnetic spectrum better than their enemies. December 23, 1944, 13:47 hours. Oberst Peltz stared at reconnaissance photographs and made decisions based on the best information available to him. Those decisions killed most of his pilots and accomplished nothing strategic. At the exact same moment, Lieutenant Morrison stood in a freezing Belgian field, next to a machine that could detect aircraft through 5,000 meters of cloud cover, and everything that happened afterward was inevitable. The Germans scoffed at American radar because their intelligence said American radar was crude, slow, and ineffective in bad weather. They were right about 1942 American radar. By 1944, the game had changed. The rules were different. The physics were unforgiving. And nobody told the Luftwaffe until it was far, far too late. The last word goes to Kowalski from that Veterans Day interview. You know what I remember most? The scope, that green glow, watching contacts disappear when we got them. Just gone. A little dot that was a person, and then empty screen. We did that 43 times on January 1st. I went home that night and couldn't sleep. Not because I felt bad. We were at war, they were trying to kill us, but because it was so easy. Point the dish, lock the target, let the math do the work. No different than tuning a radio, just colder. He paused, looking past the camera, maybe seeing something from 50 years ago. After the war, everyone wanted to talk about the brave pilots, the dogfights, the heroism. Nobody wanted to hear about radar operators and trucks. We weren't heroes. We were just guys who could read a scope and push buttons. But we ended the Luftwaffe. Not fighters, not bombers. Us. A bunch of electronics technicians with equipment that worked better than anyone expected. So when people ask me what won the war, I say guys who could do math faster than the other guys. That's it. That's the secret. No more. Calculate faster. Shoot first. Everything else is just details. The screen went dark. The recording ended. And somewhere in a museum, an SCR-584 radar unit sits behind velvet ropes. A museum piece now, relic of a war fought by people who are mostly gone. But the principle survives. In the Aegis system that defends aircraft carriers, in the Patriot missiles that guard cities, in the air traffic control network that safely routes 45,000 flights every day. All of them descendants of that ugly parabolic dish in a Belgian turnip field, operated by a 26-year-old lieutenant who understood something the Luftwaffe didn't. In the modern world, the side that sees first doesn't just have an advantage. They've already won. They're just waiting for the other side to realize it.